Good afternoon. I hope you are all doing well. Happy Easter. These are the solutions to the practice test for Chapter 4. Now, as you work through the practice test for Chapter 4, do not forget to go back and look at Chapter 5. Be sure that you're looking at solving systems of equations with two unknowns. Now, you can solve by graphing, you can solve by substitution or elimination, but you've got to also be able to do Chapter 5, solving systems of equations. We did that right before spring break. Okay, so the first couple problems that we're going to deal with are simplifying exponents. And so we're going to use our exponents rules. So our first one is 2 to the negative third power. So anytime we have a negative exponent, that means we are going to move that to the denominator. So 2 to the negative third becomes 2 to the third in the denominator. So it's 1 over 2 to the third. We're going to go ahead and simplify our 2 to the third that's in the denominator. 2 times 2 times 2 is 8. So our final answer there is 1 to the 8th power. Okay, now for the second one in this, we have 7 raised to the 0 power. And as you remember, anything raised to the 0 power is 1. Okay, so 7 to the 0 power is 1. Our next one is 8 to the 2/3 power. And what that means is, that means 8, our numerator stays with the 8. And then this is saying the cubed root. So our 2 is our numerator. The index of our radical is 3, and that's our denominator. So we're going to go ahead and do 8 squared, and 8 squared is 64. And then I'm going to take the cubed root of 64, and the cubed root of 64 is 4. Okay, so that is how we do fractional exponents. Okay, now this one is a fractional exponent or a rational exponent, and it's negative. So we're going to move that to the bottom. So I'm going to have 1 over 9 to the 3 over 2. The 3 stays with the 9. So I'm going to have 1 over 9 to the 3rd power. And then I am going to take the square root of that. So when we do 9 times 9 times 9, that is 81 times 9. Okay, so I've got 81 times 9. 9 times 9 times 9 is 81 times 9. So I am trying to find, and I'm going right here with this, so I have 1 over the square root of 729. Because 9 times 9 times 9 is 729. And I am taking the square root of that, and I get 27. So I have 1 over 27. And remember, you want to be sure that you are sitting down and using the calculator that you are going to use on your test. That is the calculator that you want to be doing with the practice test. Because you can't use your phone, you can't use your iPad, and you can't use your watch. You've got to use a calculator. So be sure you are using the correct calculator and that you know how to use that correct calculator. Okay, now we are using some of our exponent properties with variables. And so here what I have is I have a base of 4, and then I have, those are being raised to 2 different exponents. So because my base is the same and I am multiplying these, 4 to the 5x squared plus 3 times 4 to the 7x minus 9, we are going to add those 2 exponents together. So I have 5x squared plus 3 plus 7x minus 9. Now this is the exponent. We're going to put it, once we've simplified this, we're going to put it with the 4. So I've got 5x squared, and then I'm going to have 7x minus 6. When I have simplified that, that is how I have gotten that. Now that is my exponent, so it's going to be 4 raised to the 5x squared plus 7x minus 6. And it's just putting some algebra in there to practice our exponent rules. And so that is as far as we go. We're not solving for x or anything right here. Now here, our base is 7. and we are dividing. So our base stays the same. So in my answer, I'm going to have a base of 7, but I am dividing these two. So the property, the exponent rule for that means I subtract my exponent. So I'm going to have 8x plus 5, and I am subtracting 5x minus 3. And I am subtracting that entire quantity. So I have to distribute that negative. And so I have 8x plus 5 minus 5x plus 3. Okay? And that leaves me with 3x plus 8. And so my answer to this one is going to be 7 raised to the power of 3x plus 8. Okay? Now the next one is a little bit confusing. We have 4 to the z power and 5 to the z power. So our bases are not the same, but our exponent is the same. Only because our exponent is the same, only because of that right there, allows me to multiply 4 times 5 and gives me 20, and I raise that to the z power. Now let's look at that. That one's a little bit harder to kind of comprehend, so let's look at that with real numbers. Let's make z squared. Let's make the z a 2. So if I've got 4 squared, and then I've got 5 squared, okay? So 4 squared is 8, and 5 squared is 25. So 8 times 25 is, I'm sorry. 4 squared is 16. I apologize. I'm not thinking correct on Sunday night. 4 squared is 16, 5 squared is 25, and 16 times 25 is 400. Okay, so I did 4 squared times 5 squared. Now, if I do 4 times 5 and then square both of those, I would get 20 squared, and 20 squared is 400. And so that is what is going on here. Okay, the only reason that is allowed is because the exponent is the same. I'm allowed to do that because of the exponent. If the exponent wasn't the same, I couldn't do that. Okay, now for our last one right here, I have 8 raised to the power of x squared plus x, and then all of that, everything inside this parentheses right here, is being raised to the 3x. Okay, so if I had something like 8 squared raised to the 3rd power, I would multiply those two exponents. I would say 2 times 3, and I would get 8 to the 6th power. So we are going to use that property right here. So I am going to say x squared plus x times 3x. Okay? So I have x squared plus x times 3x, and we're going to have to distribute that 3x. Okay, so I have x squared times 3x, that's going to be 3x to the 3rd, and then I have 3x times x, which is going to be 3x squared. And so that is my exponent. So I'm going to have 8 raised to the power of 3x to the 3rd plus 3x squared. And what's happening in these is it's really getting you to think about your exponents. That's what's happening here, is we are thinking about our exponents. Okay? Okay, now we are looking at solving exponential equations. And the way that we solve exponential equations is we try to get their base to be the same. Because once their base is equal to each other, then their exponents are equal to each other. So if I've got a to the x power, and that is equal to a to the y power, then I am able to say that x is equal to y. So when I am looking at exponents like this, the first thing that I do is I see if I can rewrite either of them with the base of the other. Okay, so I've got 3 to the 4x plus 5, and then I have 9 to the x plus 1. So what I would look at is I would look at my 3 and I would look at my 9, and I would see, can I rewrite one of those? And I can rewrite 9. So I am going to keep my 3 written as 3. So I'm going to say 3 to the 4x plus 5. Now I can rewrite my 9 as 3 squared. Okay, now 3 squared is 9, and that is being raised to the power of x plus 1. So what I have here is I have 3 raised to the second power, and then all of that is raised to x plus 1. So I'm going to have to use my exponent properties there. So I'm going to rewrite 3 to the 4x plus 5. And when I raise a power to another power, I multiply. So this is actually going to be 3, and I'm going to multiply x plus 1 times 2. So I'm going to get 2x plus 2. So I've used that power to a power property. Now that I have my bases the same, I can say that my exponents are the same. So I have 4x plus 5 equals 2x plus 2. Okay? And so I am going to solve. I'm going to move my x's together. So I'm going to subtract 2x from both sides. And when I do that, I end up with 2x plus 5 equals 2. I subtract 5 from both sides. And when I subtract 5 from both sides, I end up with 2x equals negative 3. Okay. I divide by 2. And I get x equals negative 3 over 2. Okay, and you do want to go back and check that. It's always a good idea to go back and check. And I'm not going to do that just to save us some time, but you plug negative 3 over 2 back in for x, and you make sure it all works out. Okay, so now let's do the next one. I have e to x squared plus 4x equals e to the 2x plus 48. These are already set equal to each other with the same base. So all I have to do is write my exponents equal together. So I've got x squared plus 4x equals 2x plus 48. So this is going to be a quadratic. So I have to set it equal to 0. So I have x squared. I'm going to subtract 2x from both sides, okay, because I'm moving towards getting it set equal to 0. So I'm going to subtract 2x from both sides. So I'm going to say 2x, okay, and then I'm going to subtract 48 from both sides. And once I do that, that is equal to 0. Okay, so now I've got x squared plus 2x minus 48. I can factor that. And when I factor that, it factors to x plus 8 times x minus 6. And the reason for that is because 8 times negative 6 is negative 48, and 8 plus negative 6 is positive 2. I'm going to set each one of these equal to 0. And so my final answer here are negative 8 and positive 6. And again, you want to go back and check just to make sure you're on the right track. These problems, you don't have extraneous solutions. Sometimes when you square both sides and when you're doing logs, you always want to go check. You're not really checking for extraneous solutions here, but checking is always a good idea. Okay? Okay, let's move to the third one. This one you have to think a little bit harder. You've got 1 over 7 to the 3x equals 49 squared. So we're trying to get both of these in terms of 7. Now this 7 to the 3x power is in the denominator. So if I take it to the numerator, I can rewrite that as 7 to the negative 3x. Okay, and that's all I've done is I've moved this denominator to the numerator, and when I do that, I make it its reciprocal, and so my exponent becomes the negative. Now, I can rewrite 49 as 7 squared, but 49 was raised to the second power. So again, we've got this power to a power that we've got to deal with, and you deal with that by multiplying. So I have 7 to the negative 3x equals 7 to the 4th. And when those are equal to each other, when the bases are the same, that means the exponents are the same. So I have negative 3x equals 4. I'm going to divide both sides by negative 3, and I'm left with 4 over thirds, and that's negative. So my final answer here is negative 4 thirds. Okay? Okay. And this one is not as bad as it seems. 5 to the x plus 8 equals 1. 5 to the x plus 8 equals 1. Now, we've talked about these not, like, what do we do when they're not the same base? And it would appear at first glance that this is not the same base. And when we do that, when we don't have something to the same base, then we have to take the log of both sides and we move on from there. But anything raised to the 0 power is 1. So could I rewrite this as 5 to the x plus 8 equals 5 to the 0 power? Have I changed the value of anything if I rewrite that 1 as 5 to the 0 power? The answer to that is no, I haven't. So now I've got my bases the same, so I can rewrite this as x plus 8 equals 0. So if my bases are the same, then my exponents have to be equal. And so once I subtract 8 from both sides, I have x equals negative 8. Okay? Okay, now we are getting into logs. And one of the things that you want to be sure that you know how to do is you need to be able to go back and forth between logs and exponents. So the question right now is asking us to rewrite each of these as an exponent. And as we do that, we are going to figure out what the logs are. Okay, so we're evaluating these, but the way that we evaluate them is that we rewrite them as an exponent to kind of think about what is it exactly that we're being asked to figure out. And so if we look at the first one, log base 3 of 81, the question that we are asking ourselves, 3, because 3 is my base, raised to what number gives us 81? 3 to what number gives us 81? Now 3 times 3 gives us 9. So 3 squared is 9. 3 times 3 times 3 is 27. So 3 to the third is 27. 3 times 3 times 3 times 3 is what gives us 81. So it's 3 to the 4th is 81. But the answer to this log is that exponent. Okay? So log base 3 of 81 is 3. The answer is the 3. I'm sorry, it's the 4. Oh my goodness. I've made so many different mistakes today. I think I'm just super, super tired. The 3 is our base. 3 times 3 is 9. 3 times 3 times 3 is 27. 3 times 3 times 3 times 3 is 81. So our exponent is that 4. And so log base 3 of 81 is equal to 4. So the number that we are looking for right here is the 4. That's what it's equal to. Okay? Now for our next one, we are asking ourselves, 6 raised to what power gives me 1 over 36? Okay? And 1 over 36, because we're looking at a fraction, we need to think about what 6 to what power gives us 36. And if I think about that, I will remember that 6 squared is what gives me 36. So if I were to move that to the numerator, then that would be 6 to the negative 2 is what equals 1 over 36. So the answer to the second one is negative 2. And the reason for that is because if I take 6 and I raise it to the negative 2 power, that's what's going to give me 1 over 36. Okay? Now, the third one appears to not have a base. And it does have a base. It has an assumed base of 10. So you can think about this as log base 10 of 100. So the question we're asking ourselves is 10 raised to what power gives us 100? Okay? And of course, that's 10 squared. 10 squared is 100. So the answer to log of 100 is 2. Now, again, we use log base 10 a lot. Log base 10 is what we use a lot. So that is when you don't have something written down or you don't see a base included and it's log, then it's log base 10. Okay? Now, for the next one, we're looking at natural logs. And the natural logs always deal with E. And E is kind of a special number. It's an irrational number that's used a lot when we're in banking. So anytime that you see natural log, and that's an L, so ln, okay, that's your natural log of e to the fourth power. So anytime we're talking about the natural log, we're talking about base E. So we are asking ourselves, e to what power is going to give me e to the fourth power? Okay, and that's one of our properties because the natural log and the e cancel each other out. So the answer to this is just 4. Okay, so anytime you have the natural log of e raised to some power, your answer is whatever that power is. Okay? Okay. And the last one for this part, I have 7 raised to some exponent. And when I raise 7 to whatever this exponent is, I get 1. Okay, so hopefully you've remembered that anything raised to the 0 power gives me 1. So the answer to this is log base 7 of 1 is 0. Okay, now we're going to look at number 5. Number 5 is asking us to rewrite the logarithm equation as an exponential equation. So this is where we're going from logs to exponents, and that is a super important skill for you to be able to do for this test. So you need to be able to go back and forth between logs and exponents. And so what we're going to do is we're going to take this 6. That 6 is our base. So I'm going to have 6 raised to the y. The y is my exponent. The answer to a log is the exponent when you rewrite it as an exponent, and that is going to equal x. So log base 6 of x equals y. That is rewritten as 6 to the y power equals x. Okay, now we're going to do another one. So the second one is log of 4, or log base 4 of 5 equals z. So our base stays 4. Okay, this is our base right here. Z is our exponent. And our answer to that is going to be 5. I'm sitting outside and we have some people racing motorcycles. So you can probably hear all that. So log base 4 of 5 equals z. That's 4 to the z power equals 5 when we rewrite that. The third one is a natural log. And anytime we're dealing with a natural log, our base is always e. So I have e to the x power, because this is our exponent always, equals 12. E to the x power equals 12. Okay? Now, for number 6, we are going the other way. it says rewrite the exponential equation as a logarithm equation. So my base, I've got to identify my base, and I've got to work the other direction. So here I've got log, my base is 8 because the base stays the same. My of is the answer to an exponential equation. So I have log base 8 of 1 over 64, and that is going to equal x. My answer to a log, the answer to a log is an exponent. Okay, so when you are finding a log, what you are looking for is the exponent. Okay, so that's how we rewrite that one. My next one, I've got 5 squared equals y. So I'm going to rewrite that as log base 5. My answer to my exponent becomes the of. So I say log base 5 of y equals 2. And my answer to the log is the exponent from my exponential equation. So you definitely want to be able to go back and forth between those. Okay, my next one is e to the x power equals 12. Now we don't use our natural log except when we start dealing with e. So because I've got an e, that's when I'm going to use my natural log. So I have the natural log, and the natural log is automatically base e. So I don't have to write that down. But I do take my 12 and put it here. So I've got natural log of 12 equals x. And notice in this one, I don't have e written down. There's no e when I rewrite this. And the reason is because when I am dealing with a natural log, all natural logs have a base of e. And that is why. Okay? So the directions for numbers say, use the laws of logarithms to write each expression as a single logarithm. So what we are doing is we are going to use our laws and kind of put everything back to just one logarithm. So what I have here is 3 times log base 2 of x plus 4 log base 2 of y. So the first thing that I'm going to deal with is I'm going to deal with our power rule. And so I've got this 3 and I've got this 4. And those go as an exponent on each one of these. So I'm going to rewrite that as log base 2 of x to the third and log base 2 of y to the fourth. Okay? And now my next step is when I am adding 2 separate logs together, I can rewrite that, as long as they have the same base, as a single log, and the x to the third and the y to the fourth are multiplied together. Okay, so I have rewritten multiple logs as one single log because they have the same base. And so 3 times log base 2 of x plus 4 times log base 2 of y, that simplifies, and I can put it all together as log base 2 of x to the third, y to the fourth. Okay, we're going to do that again. Here I have something very similar. I have the natural log of x plus the natural log of 3y minus 8 times the natural log of z. Now the power rule is only applied right here. I don't have any numbers in front of any of these other logs. Okay, so I am just going to leave it as the natural log of x plus the natural log of 3y. And minus, I'm going to take this 8 and I'm going to put it with the z. So then I have minus the natural log of z to the 8th power. Okay, now if I am adding logs together in multiple logs, then that means if I rewrite it as a single log, those positives are going to be multiplied together. So I actually have x times 3y is what I have, x times 3y. Then if it is being subtracted, then I am going to write that as the denominator. Now I'm not including another log. I'm just taking this index right here and I'm putting it in the denominator. So I have the natural log, and I'm going to clean up my numerator a little bit, and I'm going to rewrite it as 3xy over z to the 8th. So I have taken multiple logs and I have written it as a single log. Okay, now we're going to do the opposite of that. We are going to take one single log and we are going to rewrite it as multiple logs added and subtracted together. Now, if it's in the numerator, that means it's being multiplied together, and I'm going to add those. So I have log base 6 of x squared, and I'm going to add that to log base 6 of y to the 3rd. Okay, and we'll put this in parentheses just to keep everything straight. Now my z is in the denominator, so when I rewrite that as an individual log, that's going to be subtracted, and that's because it's in the denominator. So I have log base 6 of z. Okay, and I don't have any exponent with the z. Now my power rule allows all these exponents to go in front. So I've got 2 log base 6 of x plus 3 log base 6 of y minus log base 6 of z. Okay, so for this one I have started with a single log and I have stretched it out for multiple logs using sums and differences. Okay? Now we're using some properties here that we didn't talk a ton about in class. We just kind of briefly talked about them. When your bases are the same, you can really simplify that out as 1 is what happens here. So what I want you to look at, you've got log base 7 of 7. And when that happens, your exponent is your answer. So log base 7 of 7 raised to the negative 64, that's just negative 64. Okay? So that all that stuff simplifies out and you're just left with negative 64. For the second, remember that the base of the natural log is e. So we're actually taking, so if I have the natural log of e, that's just 1. It simplifies out. So the natural log of e is going to simplify out, and I'm going to be left with just 5. Okay? And then here, this is 10 raised to the power of log base 10 of 3. Remember when we have a log and there's no base written down, that base is 10. So again, these simplify out and I'm left with 3. Okay? So the last thing that we're going to do is we're going to solve logarithmic and exponential equations. We're going to solve logarithmic and exponential equations. So when we do that, we've got to isolate our x, and this is where you're very often going to want to be able to go back and forth in between exponents and logs. You're going to want to rewrite them as exponents or rewrite them as logs. So you're going to have to go back and forth with that. So here's our first one. This is a log. So sometimes we're going to use our properties and sometimes we're going to use the definition of an exponent. So this is written as a single log. So I've got log of 4, log base 4 of x. Log base 4 of x equals negative 2. So I'm going to rewrite that as an exponent. So 4 to the negative 2 power equals x. Now I'm able to evaluate 4 to the negative 2. That's a negative exponent, so that becomes 1 over 4 squared. And so x is 1 over 16. Okay, so the answer to this is 1 over 16. Okay, now the next one is 2 log base 9 of x plus 3 equals negative 1. So we are eventually going to rewrite this as an exponent. So what I'm going to do first is I'm going to take this 2 I'm going to use the power rule, and I'm going to put it here. Okay? So I'm going to rewrite this as log base 9 of x plus 3 equals -1. Okay? Now I can write this as a single exponent. Okay, so I'm going to have 9 to the -1 equals x plus 3. Oh, you know what? I forgot my squared. So that's not going to work. Okay, so I didn't take my 2 and put it there, so I've got to put my squared right here. Okay, so I've got log base 9 of x plus 3 squared equals -1. So now I can rewrite it as 9 to the -1 equals x plus 3 squared. Okay, so then I have 1 over 9 equals x squared plus 6x plus 9. Okay, x squared plus 6x plus 9. I have just checked with the person that wrote this, and you may have had some trouble with this particular problem. So we are going to start over with this particular problem, and I'm going to put some parentheses in there because I interpreted this incorrectly, and you may have also interpreted this incorrectly. So let's go back to 2 log base 9 of x plus 3. So that plus 3 is not part of our index, okay? So that's where we're going with this, okay? So now what I'm going to do, so the x is the only part that's associated with that log. So what I'm going to do now, and this is going to make this problem a lot simpler. So on the test, I will definitely be sure to include those parentheses because that made a big difference with this one. So I am subtracting 3 from both sides because I'm trying to get that log by itself. So I am subtracting 3 from both sides here. Then I've got 2 log base 9 of x equals -4. Then if you see this 2 over here, I'm going to go ahead and divide everything by 2. Okay, so now I'm left with log base 9 of x equals -2. Okay, now I can rewrite this. So I've got 9 to the -2 equals x. And that is 1 over 9 squared. And that's 1 over 81. And so your answer to that is 1 over 81. Now, the way I interpreted it, which was not how the author intended it, I interpreted it as 2 log base 9 of x plus 3. And we didn't have those parentheses in there, and so that's why those parentheses are so important, because if they're not there, we make assumptions, and that's my fault. And then what I did was I took the 2 and made it its exponent, like this. And that was a reasonable assumption, but that 3 was not part of the index. And so then I was looking at 9 to the -1 power with this x plus 3 squared. So knowing exactly what your index is and what's part of the log and knowing exactly what's not part of the log makes a huge difference. And I apologize for my mistake there. And so this was the correct interpretation of how this was supposed to be. On your test, I will be sure to very clearly put those parentheses so that you can make sure you know exactly where those are. And I apologize for that. Okay, so let's do this one. So this one is log base 3 of x plus 2 equals log base 3 of 7x minus 3. And this one's not bad. This one's not bad at all. Because if I've got log, and this is one of our properties or one of our rules, if I've got log of m equals log of n, okay, and these logs have the same bases, then I can assume that m equals n. And that's what I'm assuming. So here, what I'm going to do, I've got log base 3 of x plus 2, and then I've got log base 3 of 7x minus 3. So because these logs are exactly the same and they have the same base, then I can drop them, and I'm left with x plus 2 equals 7x minus 3. Okay, so now I solve for x. So I'm going to subtract 7x from both sides. So I'm left with negative 6x plus 2 equals negative 3. Okay, I'm going to subtract 2, just 2, from both sides. I'm left with negative 6x equals negative 5. And when I divide, I have x equals 5 over 6. Okay, and that's my answer to that one. So now we're going to look at some exponential equations that cannot be rewritten using the same base. So like my first one, I've got 2 raised to the 3x power equals 11. And there's no way to rewrite 11 in terms of 2. So it's not going to happen. So what we have to do here is we have to take the log of both sides. So I'm going to do log of 2 to the 3x equals log of 11. Okay? Log of 2 to the 3x equals log of 11. Now I'm going to use my power rule, and I'm going to take that 3x and I'm going to put it right here. So I have 3x times log of 2 equals log of 11. Now none of this is being added and subtracted. We are multiplying everything. So we're multiplying everything here. So nothing's being added and subtracted. So the next thing that I'm going to do is I'm going to divide. So I need to get my x completely and totally by itself. And when I get my x complete, so what I've got to get rid of is I've got to divide by the 3, and I've got to divide by the log of 2. Okay, now all of this is base 10. So log of 2. So I've got x equals, and that's, I'm also dividing by 3. So I've got x equals log of 11 over 3 times log of 2. Now, if you look at your answer key, you've got something that looks a little bit different than that, and that's okay because they're both equivalent. So let's talk about keystrokes. And remember, you want to do these problems with the calculator that you're going to have when you're taking your test. You've got to be sure that you know how to do keystrokes on your calculator. So the keystrokes would be parentheses, log, and as soon as you hit log, your calculator is going to put parentheses in there. Don't forget to close that parentheses. So you've got a parentheses here and a parentheses here for your numerator. Then the 11 is inside parentheses. So please make sure that you've got your keystrokes down for that. Then for my denominator, I'm going to put parentheses again, and I'm going to say 3. And then you can hit times if you want to, but if you do 3 log, your calculator is going to assume that you're multiplying. So I've got 3 times log of 2. And again, you've got to make sure you've put 2 parentheses there, because one set of parentheses is for your denominator, and that's a multiplication sign right there. You're multiplying 3 times the log of 2. Okay? So make sure you've got those keystrokes right. So when on your calculator you have done these keystrokes, you are going to get 1.1531438, and it's going to kind of keep on going. Traditionally with logs, you go to the third or fourth. Now, because we've got a 1 over here, we're going to go to the third. So I look at the 3. I'm going to go to the third. I say, what is this 1 telling the 3 to do? And it's telling the 3 to stay the same. So my answer here is 1.153. And that's my final answer right there, 1.153. Okay, let's do the next one. Okay, now what we're going to do with this one is we are going to try to isolate as much as we can to the 4 just to see if we can rewrite it. So I've got 7 times 4, x plus 2 equals 21. The number one mistake, and this is wrong, the number one thing that students want to do is they want to say 7 times 4 is 28, and they want to say 28 x plus 2 equals 21. That is wrong. It is incorrect. You cannot do it that way. It is not right. Okay? Don't do it. So what we're going to do right here is we're going to divide both sides by 7. Okay? And when I do that, I have left my 4 x plus 2 by itself, and that equals 21 divided by 7, which is 3. Now, there is no way that I can rewrite that. 4 to the x plus 2 equals 3. 4 cannot be rewritten as 3 to some power. 3 cannot be rewritten as 4 to some power. So I have to take the log of both sides. So I'm going to say log of 4 x plus 2 equals log of 3. So our power rule then tells us to take that x plus 2, and we're going to put it in front of the log. Now remember, log of 4 is just a number. Okay, we don't know what that number is, but it's a number. You know, I can take log of 4. It's pretty straightforward. So I've got to distribute that log of 4. So I have x log of 4 plus 2 log of 4. And that's definitely the step that students don't know what to do. They're just, they don't realize that they've got to distribute this to both of these. So this is the step that students get confused. So just kind of hang in there and realize that's what you've got to do. You've got to distribute that log. And I know that it's a little bit confusing, but that's what you do. Okay, now remember, anytime I've got log 4 or 2 times log 4 or log 3, those are just numbers. So I'm going to treat those the same way that I would treat numbers. So I am going to subtract. I still want to get my x by itself, so I'm going to subtract 2 log 4 from both sides. Okay, and when I do that, I'm left with x log 4 equals log 3 minus 2 log 4. Okay, log 3 minus 2 log 4. So my next step then is to divide everything by log of 4. Okay, so my answer is x equals log of 3 minus 2 log of 4 over log of 4. Okay, so again, we've got to figure out those keystrokes. Make sure we do those keystrokes correctly. So I'm going to do my keystrokes in red. So I've got to do my numerator first. Numerator. Okay, so I have log. As soon as I hit log on my calculator, I'm going to get a parentheses. So my 3 is in my parentheses. Minus 2, you can put multiply if you want, log of 4. Now here you've got to put 2 parentheses. You are closing the 4 and you are closing the numerator. So don't forget to do that. Now I would go ahead and get in the habit of putting both your numerator and your denominator in parentheses. And so here you have parentheses log of 4. Your 4 is in parentheses, and then you close that. So those are your keystrokes. Okay, so when we do this on the calculator, and remember, be sure you are practicing on the calculator that you are going to use during the test on Tuesday. Be sure you are doing that. When we do that, we get negative 1.207518. You want to make sure there's at least 4 digits in there. In this one right here, we're going to round to this space. So I look at my 5, and it actually tells my 7 to go up. So for this one, I'm going to have negative 1.208 as my final answer. And it is an approximation, but there it is, negative 1.208. Okay, I think we've got one more. Okay, so here I've got 2 times e to the 5x plus 2 minus 3 equals 15. So what we are going to do here is we're going to try to isolate the e as much as we can. So I'm going to add a 3 to both sides. Okay, so I have 2e to the 5x plus 2 equals 18. I'm going to go ahead and get rid of that 2. Okay, so I'm going to go ahead and get rid of the 2. So I have e to the 5x plus 2 equals 9. Okay, now I'm going to go ahead and take the natural log of both sides, because when I take the natural log of both sides, I'm keeping everything equivalent as long as I do it to both sides. So I'm going to take the natural log of both sides. Okay, so I've got the natural log of e to the 5x plus 2 equals the natural log of 9. Now, if you remember, when I have the natural log of e, that cancels out because the base of a natural log is e. So the natural log of e is going to simplify out. So I am left with 5x plus 2 equals the natural log of 9. Sorry, and I wrote that 9 like an exponent, and I shouldn't have. So I've got 5x plus 2 equals the natural log of 9. So I'm going to go ahead and continue solving for x. So 5x plus 2 equals the natural log of 9. I'm going to subtract 2 from both sides. Okay, so I've got 5x equals the natural log of 9. That stays together. That 9 belongs to the natural log. So I cannot say 9 minus 2 is 7. So it's got to be the natural log of 9 minus 2. Those are separate things. Think of that as the same value that we think of exponents. That's where logs go when we're talking about order of operations. So I can't do anything. I can't do 9 minus 2. Now I'm going to divide both sides by 5. And so my answer is x equals the natural log of 9 minus 2, and all that's in my numerator, over 5. And again, I want to talk about keystrokes, and you've got to keep everything in that numerator together. We've got to keep all of this stuff together. So keystrokes, I'm going to have the natural log. As soon as I hit natural log, it's going to give me a parentheses. So I've got the natural log of 9 minus 2, and I'm going to close that parentheses. Then I'm going to divide by 5. Okay? So be sure you are doing your keystrokes correct. So always make sure you've got your keystrokes correct. That's going to make a huge difference. So once I do the natural log of 9 minus 2, and then I divide that entire quantity by 5, I get 0.0394449. Okay, so we're really looking at about 4 decimal places on this one because we don't have a 1 there. So we're going to round 1, 2, 3, 4. We're going to go to this right here. This is how far we're going to go. So we're going to look at this 4, and we're going to see what that tells us to do, and that tells us to stay. So my answer to this is 0.0394, and that is my final answer. Okay, Don't forget chapter 5. Don't forget to look over those, systems of equations with two variables. Also, don't forget that you want to be sure you are practicing these with the calculator that you are going to use on Tuesday. Okay? Let me know if you have any questions. I'll talk to you soon.